This sub-VI accepts a bit stream as an input and interprets this bit stream as a series of text characters. I'll begin by creating the control for the bit stream input. Next, I want to group the bit stream into 8-bit values, or 10-bit values if we have framing bits instead. But I'll start out with the notion of 8 bits for now. We want to reshape this array into a two-dimensional array of n by 8 for the dimension. So we need to determine the array size of the incoming bit stream. And once we know the size, we can then divide that value by 8 if we had 8 bits per character. We then take the quotient, and we need to say that now this quotient is applied to essentially the n, or the vertical dimension of our array. Now let's talk about whether or not the value is supposed to be 8 or 10. You would want to rename this control to match the specified name, but we say that if this control is true, then the value is whatever you connect on the top, and the other value then is whatever you need in the otherwise case. So we say if the Boolean control is false, then we generate the value 8. This value then can be used as the divisor. And again, we take the quotient output to indicate the first dimension, which would be, I think of that as the number of rows. The second dimension then would be the number of bits per row. Now once we have it in this form, we can convert the pattern back into a numerical value. So I had to go through a couple steps here. Now this only works on one-dimensional arrays. So I'm going to put this inside a for loop so that we can then step through each of the 8 or 10-bit words. So this converts the binary pattern into its numerical equivalent. And once we have the numerical equivalent, we can convert that to its ASCII representation. Now I'm noticing a coercion dot appearing here. Let's investigate that a little bit more thoroughly. This is really wanting an unsigned 8-bit value, or the U8 data type. But this is generating a 32-bit integer, and so that's why we're seeing the coercion. You could probably get away with it, but just to ensure that your meaning is clear, let's go ahead and actually convert the results of Boolean array to number to an unsigned 8-bit data type, and that takes care of the coercion dot here. So we now have created a string representation from our original bit stream. Now I have just a little bit more work here associated with handling the framing bits. The version that I'm showing here is assuming that there are no framing bits. Now this case structure is something that you would want to go inside the for loop. I'm just putting it here since I'm running out of space horizontally. The case structure needs two different options. One where we remove the framing bits when our Boolean control is true. And then the second case says, what do we do if there are no framing bits? Alright, the main idea behind removing the framing bits is we'd like to be able to extract a subset of the either 10-bit Boolean array. If we know there's framing bits, then it's going to be 10 bits. Then we need to specify the length and the index. So length says how many bits do we actually extract, and index says where do we start. Well, I want to start at 1 bit in, so that would be index number 1, and I want to actually extract 8 bits, so that would be the length. Now I'd like to point out this is where you can find some things for making tests on your framing errors.